Okay, so we're going to do two examples from this practice two sample confidence intervals. So we'll read through the problem. A surprising number of young adults aged 19 to 25 still live with their parents. A random sample by the National Institutes of Health included that 2,253 men and 2,629 women in this age group. The survey found that 986 of the men and 293 of the women lived with their parents. Construct and interpret a 99% confidence interval for the difference in the true proportions of men and women age 19 to 25 who live in their parents' home. So what I do want to note is even in this sentence, this is our parameter right here. This is our parameter of interest, this difference. And they even told us the order for us, which is great. We want to do the difference in true proportions of men and women. So, well, kind of, I guess you could read that either way, but I'm going to go men minus women because there is a higher number of those, I believe. Usually we just write it where it's positive, but let's go through our state, plan, do, conclude format. So we're going to state, name the parameters of interest and the confidence level. So notice parameters because we have two different populations. So these are about proportions, and I'm going to go ahead and write all this stuff down too. So we have our sample size for men is 2,253. Our sample size for women is 2,629. And I'm going to go ahead and write down my X's too, right? How many of those still live with their parents. So my X, the number of males that still live with their parents was 986. And my number of females who still live with their parents was 923. And remember that our P hat for men is simply X over N. If you wanted to calculate that just for funsies, our calculator will do it for us, but it's still kind of nice sometimes to have an idea what those proportions are. So if you were interested, remember P hat's just X over N. So that would be 986 divided by 2253, which is about 0.44. Our sample proportion of women who still live in that age group that still live with their parents is 923 over 2,629. So 923 divided by 2,629, which is about 0.35. All right, so as we state our parameters of interest and name our confidence level. So we're going to estimate this PM minus PW with a confidence level of 99%. And I'm going to and instead of calling it 1 and 2, I almost always use letters because I don't like to keep up with what the numbers mean. So to me, M and W make sense. It's about men and women. So I'm going to say, let PM equal and let PW equal. So our PM is going to be the proportion of men, of males aged 19 through 25 who live with parents. And P sub W is going to be the proportion of women in this age group who live with their parents. Oh no, it's frozen. There it goes. All right, there we are. Sorry about that. Okay. It was frozen for quite a little bit too. So if you need to pause it to go back and write those things, go for it. So again, we're going to be estimating the difference of the proportion of men minus the proportion of women. That's what we're going to estimate with 99% confidence. And we're going to let PM equal the proportion of men in this age group who live with parents. And P sub W is going to be the proportion of women in this grade group who live with their parents. All right, so our plan, we're going to name the test. Now, this is about proportions. So this is going to be a 2 proportion Z interval. And I'm going to go ahead again and remind myself, this is going to be for PM minus PW. but we're using a 2 proportion Z interval to find the difference in the proportion of men minus the proportion of women. And then we're going to check those conditions: random, independent, and normality. For random, they did tell us that they are a random sample of men and women, so misstated for both. For independence, we are going to go 10 times 2253, and we'll do 10 times 2,629, which is, yeah, there we go, 22,500 and 26,2,900. And those are less than or equal to the population of men in this age group and women in this age group. So that's reasonable. And for normality, we're going to go NP, but it's really P hat, and that has to be greater than or equal to 10. And I'm going to do this one for men first. So for men, we actually know, so you can multiply it if you want. You could do N 2,253 times my P hat, but they actually tell us how many successes we have. There are 986. So I have 986, which is greater than or equal to 10. And then I can also do failures in 1 minus P for men. So we're doing men first. So if 2,253 men, of those 2,253, 986 of them did live with their parents. That means 1,267 did not, which are both greater than or equal to 10. I have to do the same thing for females. So for females, my NP, I know that 923 of them lived with their parents, which means 2,629 minus 923, which is 1,706, did not live with their parents. Those are both, when our sample sizes are this large, it's really easy to meet that condition, but you do have to check it for both males and females. So now once I've checked the condition, I'm just going to construct the interval. Now I'm really glad that I wrote all of this stuff down in the beginning because I need that. And remember, in your calculator, if you enter this in as a whole number, 99, it'll give you an error. So remember, your confidence interval or level has to be a decimal value. Okay, so we already said that we're going to use a 2 proportion Z interval. So I'm going to go stat, test, 2 proportion, not a test, but a Z interval, 1 proportion Z interval, 2 proportion Z interval. There it is, B. Now for my X1, so you're doing M minus W, so that has to come first. Whatever is the first one in your difference. So your X1, which is our men, is our 1, is going to be 986. And our sample size for males is 2253. Our X2, which is the women, so it's whatever comes second in your difference. So it'll be 2629 and 923. I just wrote that backwards. If you were to try to write your sample size for X, it's going to give you an error, which makes sense because could I have 2,629 of 923? No, that makes no sense. So just make sure I just had mine written the other way. So 923 of those females live with their parents of the sample size of 2,629. And my confidence level is 0.99. And then calculate. And then it pops out my interval for me. Happy times. And it gives you your P hats if you are interested in that, which is nice. Okay, so for our do, we're just giving our interval, which is 0.051 and 0.123. Keep at least to the thousandth for me, but that should be good. So I just rounded to the thousandth. For our conclusion, we're just going to say we are C% confident, 99. We are 99% confident that the true, and it's going to be difference in proportion. So the true difference in the proportion of men minus women who live with their parents is between 0.051 and 0.123. And that is it. So again, we are C% confident that the true parameter, and in this case, it's a difference. And then we would say is between, and we just list that. Now, what I want you to think about, just tying this together with significance tests and just thinking about what this means. If I asked you, do you believe there's a difference in the proportion of men versus women who live with their parents? What would you say and why? If there were no difference between men and women, the proportions that live with their parents, then the difference would be zero, right? If they were the same, the difference would be zero. And then we want to ask ourselves, is zero in this interval? Because a confidence interval gives us an interval of plausible values. Notice that zero is not in this interval. So it means I do believe there is a difference between the proportion of men and women who live with their parents, because zero is not in this interval. So that's just something to be thinking about, because we always want to know, like, what does this math mean? Not only do I think there's a difference, because this is a positive number, I think typically the proportion of men who live with their parents in this age group is higher than the proportion of women who do. So there we go. All right, let's do one more together. Note this one is about means. So we're doing one for proportions and one for means. As the Hispanic population in the United States has grown, businesses have tried to understand what Hispanics like. One study interviewed a random sample of customers leaving a bank. Customers were classified as Hispanic if they preferred to be interviewed in Spanish, or as Anglo if they preferred English. Each customer rated the importance of several aspects of bank service on a 10-point scale. Here are the summary results for the importance of reliability, accuracy of account records. That seems super important. Seems like that would be very important to everyone. And then here are two groups that we're comparing, Anglo and Hispanic. So we have those sample sizes here. Notice they're not the same size, and that's okay. In real life, often they're not. And then we have their sample means and their standard deviations. And they want a confidence interval of 95%. For the difference between the mean ratings of the importance of reliability for Anglo and Hispanic customers. So for our state, we are going to name the parameter of interest and the confidence level. So our confidence level is, it says is 95%, so 0.95. And we want the difference between mean ratings of Anglo and Hispanic customers. And we're going to make it where it's positive, and we're looking at means. So I know they give us standard deviation because we need that in the calculation, but it's means that we're interested in, the mean ratings. So we're going to let mu, and I'm going to call it mu Anglo, equal the mean rating of importance of reliability for Anglo customers. And I'm going to let mu Hispanic equal the mean rating of importance of reliability for Hispanic customers. And we are going to go ahead and just write our difference. We're going to do mu Anglo minus mu Hispanic. So we just need to decide at the beginning how we're going to write that. And so my Anglo is my 1 and my Hispanic is my 2 in my calculator. Whatever comes first in your difference is your 1. All right. And then name the test. Now these are means. So our test is going to be a 2 sample T interval. And then we're going to check the conditions. So we have random, independence, and normality. For our random, it does say a random sample, so it's stated for both. For independence, we have 10 times 92 and 10 times 86, which is 920 and 860. So for my 920, that needs to be less than or equal to the population of Anglo customers. And 860 needs to be less than or equal to the population of Hispanic customers. If it is a large bank, this does seem reasonable. But if this is your bank and you do not have this many Anglo customers and this many Hispanic customers, well, then you would need a smaller sample size. But if it's a large bank, that should be no issue. So we're gonna consider that met. And for normality, it's mean. So we're either going to use CLT or they're going to tell us. Now, they did not tell us in here, but our n's are big. So for Anglo, we have n equals 92, which is greater than or equal to 30 by CLT. And for Hispanic, our n is 86, which is greater than or equal to 30 by CLT. So we are good to go. Now for the do part. So for the do, we're going to go stat, test, and it's a 2-sample T interval. So as some of you guys are going to get, just clicking stuff because you're not, just whatever you wrote down, 2-sample T interval, be sure that's what you look for. So here's T interval, but we want a 2-sample T interval. There it is, it's 0. And it is stats. We didn't enter anything into a list, they just gave it to us. And our X1, remember our ones are Anglo. So our X1 is 6.37. And our standard deviation 1 is 0.6. Our N1 is 92. Now for Hispanic. So we have our mean, our sample mean is 5.91. Our 0.93. And our sample size is 86. And we have to tell it our confidence level, which was 0.95. And always say no to pooled. It's not important. It has to do with a complicated difference in formula, which we are not doing by hand, so none of that would even make any sense. So just, it's going to automatically say not pooled. We never pool data in statistics, so we're not going to do that. And calculate. All right, and there is our interval. Look, it even gave you your degrees of freedom. We didn't have to calculate all of that ourselves, but there it is. Here you are, there's our interval. So we're just gonna say construct our interval, which is 0.226 to 0.693. Now that interpretation. So we're gonna go, we are blank percent confident. We are C% confident, 95% confident that the true. And I think this may be the hardest part for us at this stage because our parameter being a difference just sounds weird, but we'll get used to it. So we'll be like, we are 95% confident that the true difference in, and like we can look up here, in mean rating of importance of reliability, the true difference, and you can write Anglo minus Hispanic in mean rating for importance of reliability is between 0.226 and 0.693. And that's it. And so your homework is just to do the additional 2 problems on the back.